Now it is time to start bringing together what we have learned in the previous videos. First, you know the techniques now for factorizing formulas. That is, for writing a sum of multiple terms as a product. And there are different methods applying to different cases. If all the terms have common factors, then you take out those common factors and put them in front of the brackets. If they don't, maybe you can still use the sum product method to factorize them. The second thing you've learned is the principle that if a product equals 0, then at least one of its factors equals 0. And finally, I assume you know how the balance method works. And that's not part of this series, but it's basically just the idea that we can modify an equation as long as we do precisely the same on both sides. And this is how we solve linear equations. Now, when we find a quadratic equation, the basic technique for solving it is by rewriting it as a product that equals 0. So something times something is 0. And you find the factors of this product by factorizing the left-hand side of the equation. So for example, x squared minus 8x plus 15 equals 0. We factorize the left-hand side using the sum product method. So we search for two numbers, we look for two numbers whose sum is minus 8 and whose product is 15. So those numbers are going to be minus 3 and minus 5, because minus 3 minus 5 is minus 8, and minus 3 times minus 5 is positive 15. So we can rewrite this as x minus 3 times x minus 5 equals 0. And this second equation is precisely the same as the first equation. But because this is in the form a times b equals 0, we can conclude that either x minus 3 must be 0, or else x minus 5 must be 0. So this gives us two linear equations, two very easy linear equations. The first option is that x minus 3 is 0, so then x is just 3. And the second option is that x minus 5 equals 0, so then x is 5. So this is a complete solution, and the things we did here are steps that we can always use when solving equations by factorizing. So first, we make sure that the right-hand side of the equation is 0. Then we factorize the left-hand side, and then we know the principle. We use the principle that if a product is 0, then any one of its factors has to be 0. And this gives us some simple linear equations that we then proceed to solve. We'll look at half a dozen further examples, and in each example we will follow this scheme. So let's look at this one. X squared minus 16 equals 6x. First step is to check if the right-hand side is 0. Well, it's not 0 yet, so we're going to use the balance method to make it 0. It means we can subtract 6x, but we will also have to subtract 6x on the left side. So we can rewrite this as x squared minus 6x minus 16 equals 0. So now the right-hand side is 0, so now we can proceed to factorize the left-hand side. There are no common factors, so we will have to use the sum product method. So we're looking for two numbers whose sum is minus 6 and whose product is minus 16. So the 16 tells us that we probably have to do something with an 8 and a 2. The fact that this is negative tells me that I'm looking for one negative and one positive number. The fact that this is negative tells me that the negative number is bigger in absolute terms. So the answer is going to be minus 8 and plus 2. X minus 8 times x plus 2 equals 0. So now the left-hand side has been factorized. So now we can move on to using the a times b is 0 rule. Tells us that either x minus 8 is 0 or x plus 2 is 0. So these are two linear equations that we can now proceed to solve. X minus 8 is 0 gives us x equals 8, and x plus 2 is 0 gives us x equals minus 2. Second example. Is the right-hand side already 0? No. So we have to subtract 10x to this right-hand side in order to make it 0. and we will also have to do that to the left-hand side. So we get 2x squared minus 10x equals 0. Can we now factorize the left-hand side? Yeah, well, that's quite easy. Both have a factor of 2x in it that we can take out. So we get 2x, and then the first term, there's x left, and in the second term, there's just 5 left. So we get 2x times x minus 5 equals 0. So now we have a product that equals 0, so one of its factors has to be 0. So either 2x is 0, or x minus 5 is 0. These are two linear equations, and we can solve those. If 2x is 0, then x is 0, and if x minus 5 is 0, then x equals 5. So these are the two solutions to the equation. Next example, 2x squared plus 22x plus 56 equals 0. The right-hand side is already 0, so we can move on to factorizing the left-hand side. But that's a bit difficult. This is a form where the sum product method is what we should use, but that only works if the first term is just x squared. So we first want to divide everything by 2. Can we do that? Well, yes, we can divide everything on the left-hand side by 2 if we divide the right-hand side by 2 as well, and that's easy because 0 divided by 2 is just 0. So we divide this by 2, we get x squared. 22x divided by 2 is 11x, and 56 divided by 2 is 28. So now we are ready to start factorizing the left-hand side. Using the sum product method, we look for two numbers whose sum is 11 and whose product is 28. 28, there aren't so many options, and the option we're looking for here is 28 is 4 times 7, and 4 plus 7 is 11, so that works. So x plus 4 times x plus 7 equals 0. Using the a times b principle, this means that either x plus 4 equals 0 or x plus 7 equals 0. And then solving the remaining equations, if x plus 4 is 0, then x has to be minus 4. And if x plus 7 is 0, then x has to be minus 7. So these are our solutions. Next example, is the right-hand side in this equation already 0? Yes, it is. So we want to move on to factorize it, but then we see that this is already a factorized form. It's not perfect actually, because we could take out some further factors here, but it's good enough for solving the equation. So let's just leave it as it is and say we have a product here of two factors. 8x times 6x minus 12 is 0, so that means that either 8x is 0 or 6x minus 12 is 0. Now solving these two equations separately, in the first case we get divide by 8, we get x is 0. In the second case, we want to add 12 to both sides of this small equation first, so we get 6x equals 12, and then we divide by 6, so x equals 2. So the two solutions are x equals 0 or x equals 2. Example 5. This may look like it is already factorized, but in the first step we see the right-hand side should be 0, and in this case the right-hand side is 7, so that doesn't work. So we multiply this out, x squared, and then x times 4, and then minus 2 times x, and then minus 2 times 4. So x squared plus 4x minus 2x minus 8 is 7. And now we're ready to take away this 7, because we know that we then get x squared, and then this simplified is plus 2x, and then minus 8 minus 7 is minus 15. So we get, in the end, we get x squared plus 2x minus 15 is 0. And now finally the right-hand side is 0. So now we can start factorizing the left-hand side again. And now we're looking for two numbers whose sum is 2 and whose product is minus 15. A negative product, so one positive and one negative number. And the positive one is a bit bigger because the sum is positive. So 5 and minus 3 looks like a good option. 5 times minus 3 is minus 15. And 5 minus 3 is 2. So we can start factorizing. X minus 3 times x plus 5 equals 0. Now we have a product that equals 0. So we use the a times b rule. Either this factor is 0 or this factor is 0. and we can easily solve these remaining equations, x equals 3 or x equals minus 5. Last example, example 6. 1 over 3x squared plus 2x plus 3 is 0. The right-hand side is already 0, so we can start factorizing the left-hand side. We are going to use the sum product method, but in order for that, the first term has to be x squared. So we want to multiply this term by 3 in order to get rid of the fraction here. And we can do that if we multiply all of these terms by 3. Then we have multiplied the entire left-hand side by 3. And we are allowed to do that if we also multiply the right-hand side by 3, which is easy because 0 times 3 is just 0. So we can start multiplying all of these terms by 3. Then this becomes x squared, this becomes 6x, and this becomes 9. And the right-hand side stays 0, which is nice. So when factorizing this, we look for two numbers whose sum is 6 and whose product is 9. Well, 9 is 3 times 3, and 3 plus 3 is 6, so that works. X plus 3 times x plus 3 is 0. And that means that one of these factors has to be 0. Well, both factors are the same, so actually we have less work to do because the only option is that x plus 3 equals 0. And if x plus 3 equals 0, then that means solving this simple linear equation that x equals minus 3. So pause the video and see if you can do this by yourself. And we will look at the solutions. The right-hand side is already 0, so we can factorize the left-hand side. Both terms have a factor of x. So we get x times x plus 5 equals 0. So x is 0 or x plus 5 is 0. This is a solution, and this gives us as a solution x equals minus 5. Here we have to factorize using the sum product method. Look for two numbers with sum 5 and product 6. Well, 2 times 3 is 6 and 2 plus 3 is 5. So x plus 2 times x plus 3 is 0. And then either x plus 2 is 0 or x plus 3 is 0. So x is minus 2 or x is minus 3. Here we again have to use the sum product method, but now the sum is 6 and the product is 5. So our numbers are going to be 5 and 1, because 5 times 1 is 5 and 5 plus 1 is 6. So x plus 5 times x plus 1 is 0. So that means that x plus 5 is 0 or x plus 1 is 0. So x is minus 5 or x is minus 1. Here the right-hand side isn't equal to 0 yet, so we'll have to subtract 6 on both sides in order to make it 0. X squared plus 5x minus 6 is 0. We need to use the sum product method again. So we're looking for two numbers whose sum is 5 and whose product is minus 6. This is a negative product, so that means we're looking for a negative and a positive number. And the positive number has to be bigger because the sum is positive. So what could work is minus 1 times 6 is minus 6, and minus 1 plus 6 is 5. So our numbers are minus 1 and 6. So we rewrite the left-hand side as x minus 1 times x plus 6 equals 0. Then x minus 1 is 0 or x plus 6 is 0. So x is 1 or x is minus 6. In exercise E, we are lucky. This has already been, the right-hand side is 0, and this has already been factorized. So we can just say that either x minus 2 is 0 or x minus 3 is 0. So x is 2 or x is 3. In the final exercise, we are less lucky. This is a product, but the result is 6, not 0. So we'll have to simplify this entire product first and then remove the 6 on the other side. So we're going to multiply this out, x squared minus 3x minus 2x and then plus 6 equals 6. Well, it's going to be relatively easy then. We can simplify these two terms, we can bring them together. So we get x squared minus 5x plus 6 equals 6. And then if we subtract 6 on both sides, we just get x squared minus 5x equals 0. And we can factorize this because both terms have x as their common factor. So we get x times x minus 5 equals 0, which means that either x is 0 or x minus 5 is 0. So x is 0 or x is 5. Now, if you knew how to do this and you've come this far, then congratulations. You now understand the basics of solving quadratic equations by factorizing. We're not completely finished, though. There are cases where factorizing is not your best option. And also, we still need to look into what solving quadratic equations means in a geometrical sense. When we look at the graphs of formulas, what does the solution to an equation actually tell you? And of course, what is the use and the application of quadratic equations in broader mathematical or practical questions? And we will delve into these questions in the final videos. But as for the technical algebraic part of this series, you've made your way through it, so well done. And of course, don't forget to keep practicing these techniques so that you gain more confidence, speed, and accuracy.